Hi, and welcome to our video on solving literal equations. Literal equations are equations that contain more than one variable, and you're solving for a different variable. So I'm just going to give you a variety of examples. Each equation that you're given involves using a different strategy, so practice is the key here. If we look at our first equation, they're asking us to solve for L. Right now, the equation has been solved for A. So in general, you're going to use opposite operations. This is a fairly easy problem. So if we're taking a look at this one, if we want to get L by itself, we first need to get this whole term by itself. So we need to move the plus 2 to the other side. So we're going to use opposite operations. We're going to subtract 2 from both sides. Let me use a different color here so you can see it. So we're going to subtract 2 from the right side. So we need to subtract 2 from the left side. And when we do that, we don't need to actually do much math. That's the beauty of literal equations. We're just going to string our terms along. Let me move this so it's under the 2. So when we subtract 2 from both sides, we are left with a minus 2 on the left side, a minus 2. And on the right side, we have L times W. The plus 2 and the minus 2 canceled each other out. So now our goal is to get L by itself. So we need to get rid of the times W. So we're going to use the opposite operation, and we're going to divide both sides by W. We're going to divide the right side by W. So we need to divide the left side by W. And everyone is going to get divided by W. So what we're left with on the right is L by itself, which is what we were hoping for. Let me put this down. Oops. Equals L. On the left side, there's no algebra we need to do. We cannot do any subtraction or division, so we're just going to leave it as we see it. Our left side is A minus 2 divided by W. The whole thing was divided by W, and that's our final answer. We solved our equation for a different variable. So this whole equation right here, A minus 2 all over W equals L, is our answer. We solved that equation for L. Let's try a different one. This one's a little trickier. So this is the volume formula for a cylinder. Right now it's solved for volume, but they want us to solve for R. So we need to get R by itself. Here's our variable that we want to get by itself. So we need to get rid of the 1/3, the pi, the h, and then we also need to deal with the squared. So our first step, I think, should be to get rid of the 1/3. Let's clear the fraction. So we need to ask ourselves, what do we multiply both sides by to get rid of the 1/3? Let me try that again. I was going for parentheses. Yeah. What can we multiply this side by to clear the 1/3? That's 3 over 1, or 3. If we multiply this side by 3, we also have to multiply the left side by 3. So what we get is 3W, or 3V on the left side. On the right side, the fraction goes away. So we're just left with, let me write it because it's easier, pi r squared h. The 1/3 and the 3 canceled out. So again, our goal is to get R by itself. So now we need to get rid of the times pi and the times h, and we can do that in one step. I can divide this whole side by both pi and h. And I can divide by pi. Pi is just a fancy number 3. And so if I can divide by 3, I can divide by pi. So I'm going to divide by pi and h. What I do to one side of an equation, I must do to the other side. So I'm going to divide by pi h. And what I'm left with on the right, well, the pi cancels with the pi on top, cancels with the pi on bottom, and the h on top cancels with an h on the bottom. And so we're left with r squared on the right. And over here, again, there's no algebra to do. We're left with 3v over pi h. And that's okay. We just leave it like that. There's no simplification necessary there. Okay, our last step is to get R by itself, so we need to square root. So we're going to square root the right side, so we must square root the left side. And square rooting just gets rid of the square. They're opposite operations. So on the right, the square root cancels with the square, and we're just left with r, which is what we wanted to end with. On the left, again, there's no algebra to do. We're going to draw the square root, and then we're going to say 3v over pi h, and that's all underneath that radical. We don't need to tuck a plus or minus sign out front because this is a geometry problem. This is the volume of a cylinder, and our radius is always going to be positive. So here is our final answer. This whole equation is our final answer. The square root of 3v over pi h equals r. We've solved our equation for r. Okay, let's try a different problem. Again, we might end up using a different strategy here. So they're giving us an equation, and they're asking us to solve for c. So we need to get c by itself. So if we notice right now that c is locked in with this whole term right here. Let me use a pen. This whole term has a c in it. And then we have a second term on this side, r. So first we need to move the r. If we can move the r, we're one step closer to getting c by itself. So I'm going to subtract r from both sides, minus r on the right. So I need to subtract r on the left. So when I do that, on the left, I have n minus r. And again, I can't do any algebra there. There's no algebra I can do. Just leave n minus r as it is. Okay, on the right, the r's cancel, so we're left with a plus b, the quantity a plus b times c. Okay, so many of you would be inclined to distribute the c now. But we don't want to distribute the c. If we distribute the c, then it's going to be very hard to get it by itself because it's now going to be part of two terms. If we notice, what we're looking at here is one quantity times another. We have the quantity a plus b times c. So to get rid of the a plus b, we're going to divide. We're going to divide the whole right side by the quantity a plus b, and we can do that. We're going to divide by the quantity a plus b. And again, what we do to the right side of our equation, we must do to the left. So I'm going to divide by the quantity a plus b. You don't have to use parentheses, but if it helps to remind you that it is one block, that you can't split it up, you can put parentheses around the a plus b. That's fine. So what we'll notice here is that when we divide by a plus b, the term a plus b on top cancels out with the term a plus b on bottom, or I should say the factor a plus b. So what we're left with on the right is just c. Oops, I'll use the black pen. On the right, we're left with c, which is what we wanted. We wanted to get c by itself. On the left, there's no algebra to do there. We can't do any addition, subtraction, or division. So we're just going to write our answer as n minus r over the quantity a plus b. And that's your final answer. We don't need to do anything to it. This whole thing, this whole equation is our answer. That's it. We solved the equation for c. Okay, let's step up a level in difficulty. So now we're looking at this equation, and we want to solve for m. And right now, m is part of two terms. It's part of this term right here, and it's part of this term right here. So we couldn't just add gm or subtract fm from both sides, because then m would still be on both sides of our equation. So our first step here is to get m by itself on this side of the equation, meaning we need to factor out an m from the right. So remember, we decided in an earlier video, you may have noticed, that when we factor, we write an m, lowercase m, and then we put a big set of parentheses. And when we do that, when we factor out an m, what we're really doing is we're dividing everyone by m. We're dividing each of these terms by m. Oops, oh no, that's my highlighter. Hold on, let's get rid of that. I need my pen. We're going to divide this term by m. And we're going to divide this term by m. And as we said, the m doesn't disappear, it just comes out front. So in this first term, when we divide by m, the m's cancel, and we're left with an f. And in this second term, when we divide by m, we're left with just a g. So inside of our parentheses now, we're going to have just f minus g. And this was an equation we can't forget. So we had t equals on the right side of our equation. So our next line, looks like t equals m times the quantity f minus g. Maybe I'll rewrite that because that's hard to see now. It's not aligned. T equals m times the quantity f minus g. And now we need to get m by itself. So what we're saying is m times the quantity f minus g. So we need to use division to get m by itself. So we're going to divide both sides by the quantity f minus g. And when we do that, m will be left alone. So we're going to divide the right side by f minus g. So we need to divide the left side by f minus g. And again, if you would like to put parentheses to remind yourself that you can't split them up, you may, but it's not necessary. This is a quantity. So when we do that on the right, the f minus g cancels out, and we're left with m. So we have, let me write this. On the left side of our equation, we have t, we have the t over the quantity f minus g. That's what's on the left side of our equation. On the right side, m is now by itself, like we wanted. So this is our final answer. This whole equation is our final answer. T over the quantity f minus g equals m. So in this problem, I want to highlight, we had to start by factoring out, I'm going to write it on the slide. We started by factoring out m from both terms. So in this one, we had to start by using our factoring knowledge. Okay, last one. Let's take a look. Here we have an equation, and they want us to solve for a. We need to get a by itself. So here's a. There are two terms on the right side of our equation. So our first step should be to get this term by itself. We need to add 1 over b to both sides of the equation. So I'm going to start by adding, let's get rid of our highlighter. I'm going to add 1 plus b. I'm going to add 1 over b to both sides. I'm going to add it to the right, so I need to add it to the left. That's okay. When we do that, on the right side, we're left with 1 over a, because our 1 over b's canceled. On the left, we can't do any algebra. We're just going to string our terms out. C plus 1 over b. Okay, right now, at this step, a is in the denominator. So our goal needs to be to get to combine both this c and this fraction. Because if we do that, at the end, we can flip our fractions. If a is in the denominator, we need to take the reciprocal of both sides of our equation to get a into the numerator. So our goal right now is to combine these two terms. And in order to do that, we need to get a common denominator. And our common denominator should be b. So if our common denominator is b, I need to multiply the bottom of this fraction and the top of this fraction by b. So we don't change the value, we're just changing the way it looks, because bc over b is still c. But now we have a common denominator. Now b is our common denominator on the left. And our numerator is bc plus 1. bc plus 1. So what we've done is we turned the left side of our equation into one fraction. We took c plus 1 over b and we used our common denominators to add them together. And now we're almost there. Again, our goal is to solve for a, to get a by itself. So now that there's one fraction on the left and one fraction on the right, I can just do the reciprocal of both sides. If I do the reciprocal on this side, I need to do the reciprocal on this side. Really what we're doing is raising both sides of our equation to the -1 power. When we raise both sides of our equation to the -1 power, we just take the reciprocal. So our final answer is A. Let me get my pen out. If we take the reciprocal on this side, we get A over 1, which is A. If we take the reciprocal on the left side, B is now in the numerator, and BC plus 1 is now in the denominator. There we go. We solved for A. So let me go back up so we can see it. We added 1 over B to both sides. And then we had the equation C plus 1 over B equals 1 over A. And we decided, okay, I'm going to need to flip the fraction on the right side. So I need to turn the left side of my equation into one big fraction. So I used common denominators to combine C plus 1 over B down here. And then once I had one fraction on this side and one fraction on this side, I could raise both of them to the -1 power, meaning I could take the reciprocal of both sides. And now A is by itself. So here, this whole thing is our answer. We solved this equation for A. You may experience other literal equations problems that combine these skills. Square rooting, factoring out a common factor, taking the reciprocal of both sides or common denominators. You need to be able to use these flexibly as the good problem solvers that you are.